Okay, welcome to another video where I take a look at one of our class workshops and see how to do 1 and 2 sample t-distribution inference. So this example is about this herbal supplement called Garcinia Cambogia, which apparently people say can help you lose weight. There's one very famous celebrity doctor, Dr. Oz, who you may have heard of. He used to be on Oprah Winfrey a lot, and now he has his own show. Here's a picture of Dr. Oz. Anyway, he's a little bit controversial because he sometimes advocates things like these herbal supplements that don't have strong evidence that they work. And so this is an example of that. So Garcinia Cambogia has been studied, and this is one example of a study that was done this was from 1998. They got 135 people who were all trying to lose weight to participate in a study. And it says here, this in the box right here is an abstract from the study. So this is exactly the way the scientists who wrote the paper reported their results. It says a total of 135 subjects were randomized to either active hydroxycitric acid, which is the active ingredient of Garcinia Cambogia, and the number of people there was 66, or a placebo, and the number of people there was 67. And then they say how many people stuck with it for 12 weeks of trying to lose weight. And then it turns out at the end of the 12 weeks, patients in both groups lost a significant amount of weight. However, the differences between the two groups were not statistically significant, and they give the numbers here, and I've just recorded all those numbers down in this table here. So let's run through the answers to all the questions. Hopefully everybody's had a chance to look at this one already and already has answers ready to go to check. Okay, number one, this is an example of a randomized controlled experiment. Why is it important to use a randomized experiment in this situation? So this is going back to the chapter about experiments, right? We're going to keep going back to old stuff in the course. And so this is one of those big concepts in the course. Why do you do experiments? Well, a randomized experiment lets you show cause and effect, right? Because by randomizing the people, all of the possible lurking variables are sort of controlled for, right? You should get about the right numbers of men and women and the right numbers of older and younger people in each of these groups. So none of those should be lurking variables. So the only difference is the treatment they're getting, the herbal supplement or the control. Okay, the second question was, what are the explanatory and response variables? Okay, so explanatory. Well, we think that the Garcinia Cambogia might help people lose weight. So that's the explanatory variable, whether they got the Garcinia Cambogia or a placebo. The response variable is the amount of weight that they lost, right? And another thing you might want to think about is which of these is categorical, which of these is quantitative. Weight loss is quantitative. And so you can talk about things like average weight loss. And so that's why we're using t-distribution techniques. Okay, number three, according to the study, patients in both groups lost a significant amount of weight. It's a little bit surprising if you think about it that people taking a placebo still were able to lose a significant amount of weight, but I guess these were all people who were trying to lose weight. They were all participating in a study, and so I guess they were all on a diet of some kind. And so, so you can lose weight even if you're not taking Garcinia Cambogia. I guess that's not that surprising. But anyway, it says they lost a significant amount of weight. So what do they mean by that? Well, it means they did a t-test. And so we're going to do the same thing. We're going to see if we agree with them. And so the hypothesis of this one sample t-test would be for the one group we care about, the placebo group. Did they lose a significant amount of weight, or was there no difference in weight? So the mu here is the average for the population of everybody taking a placebo, not just our 60 some odd people, but if we got lots of people to take a placebo pill and try to lose weight over 12 weeks, how much would they lose on average? The null is that they wouldn't lose anything. There'd be no difference, and so they would have 0 pounds of weight loss. The alternative is, no, maybe if you're trying to lose weight, you'll lose more than nothing. Okay, that's the alternative. Those are the hypotheses for our one sample, the placebo sample. Now, the t-value for the placebo sample is we look at the data, and the data says that in the control group, the placebo group, they lost 3.2 kilograms of weight on average. That was the sample mean. And that's more than the null hypothesis said they should have. They should have only lost 0. Okay, so the difference here is we want to find out if that's significant. So we're going to see how big it is relative to the right standard deviation. So we divide by the standard deviation, also from the table, 3.3, and then the square root of the sample size. And the sample size, it says n was 42, and that's because 42 of the people stuck with the program for 12 weeks. Okay, we get a t-value of 6.28, and then you look up the p-value for that using either the chart or the app. I recommend the app. It's much easier. And when I put this in the app, I got 0, which just means that this is so low that the odds of this happening just by chance, that you'd see a number this big if the null hypothesis is true, are astronomically small, basically 0. So this wouldn't happen by chance, which means that in a sample like this, if you see something like this happening, it's not a fluke. It's a real thing that's going on. It's probably reflecting the population, almost certainly. Okay, so that is very significant. That's not really what the study was about, though. The study was about whether Garcinia Cambogia works better than a placebo. And so now we need to compare two different groups. And that's why we're going to use a 2-sample t-test in the second part, in part 4 here. And so now our hypotheses are comparing two different groups. So the null is that there will be no difference between the population mean weight loss of the Garcinia Cambogia people and the population mean of the placebo people. Now the populations here are not real populations. These are hypothetical populations. You've got to imagine that what if we were to roll this out? What if lots of people were going to try to lose weight taking Garcinia Cambogia and lots of other people were going to try to lose weight taking a placebo? And if we could look at all of those people and see how much weight they lost, then maybe there would be no difference. That's the null hypothesis. Or maybe the Garcinia Cambogia really does work better than a placebo. And so we can do a one-sided test to see if there's a significantly higher weight loss in the Garcinia Cambogia group than in the placebo group, which would mean that we would lean towards the alternative being true. Okay, so the formula for doing a 2-sample t-test is this formula. I've already plugged the numbers in, and this is the t-value that I got. Once you get the t-value, the next step is to find the p-value. Again, use the app. I got 13%. And that is not significant evidence, right? It's not below 5%. So this is definitely not significant evidence. And so what does that mean? Well, that means that this might just be a random fluke, what we're seeing here. This is the kind of thing that would happen 13% of the time if the null hypothesis was true. So yeah, that could just be an accident. And that brings us to number 5, where I basically ask, what is this? What does it mean when you say something is not statistically significant? So you just have to remember, statistically significant isn't the same as the word significant in English. In English, significant means big or important or dramatic. In statistics, it means not a random fluke. So which one of these answers reflects that? Well, it's C. The observed difference between the Garcinia Cambogia group and the placebo group might have been random chance. Yeah, that's right, because when you say something is not significant, you mean it might be a fluke. Okay, cool. These other answers might sound good. They're common mistakes, but they're not right. C is the right answer. Okay, and then the last question asks you to find the confidence interval. And it also mentions that actually, in a lot of ways, confidence intervals are better than hypothesis tests, because a hypothesis just gives you a yes or no answer, right? That's what they're for, answering a yes or no question. A confidence interval gives you a range of values and can tell you something about how big the effect of Garcinia Cambogia might be. So we've already seen that it's not significant, but even if it does do something, and it might, right? Just because we rejected the null hypothesis, we didn't reject the null hypothesis, doesn't mean we're convinced that the null hypothesis is true. We just don't know, right? Our evidence is not significant, but it might still work, right? There might still be some effect of Garcinia Cambogia, but now how big is the effect? Well, that's where this confidence interval is going to come in. So we take the two different sample means. The people taking Garcinia Cambogia lost 4.1 kilograms. The people not taking it lost 3.2, which comes out to a difference of about 0.9 kilograms more weight loss taking Garcinia Cambogia, at least in our sample. But then in the real world populations of everybody, whoever would take it, we add and subtract this margin of error to try to catch the true population difference. And so that's going to be a difference that's going to be somewhere between 2.49 kilograms more weight if you add this number. And if you subtract it, it's 0.69 kilograms less weight loss for people taking Garcinia Cambogia versus people taking a placebo. So we really don't know, again, whether Garcinia Cambogia really helps people lose more weight than a placebo. It's somewhere between 2.5 kilograms, if you round this, more weight loss, and about 0.7 kilograms less weight loss taking Garcinia Cambogia. So is that a good effect size? Even if it's on the higher end of this confidence interval, even if it is 2.5 kilograms extra weight loss, that's really not a lot for 12 weeks. 12 weeks is almost 3 months of trying to lose weight. And the people taking Garcinia Cambogia, even if it's the best possible outcome in our confidence interval, it's still not a lot more. So not only do we not have significant evidence that it's working at all, but even if it is working, it doesn't have a big effect size. It's not really the kind of thing that you really probably should be going out and spending a lot of money on. It's definitely not the cure to obesity. So there we go. That's how you would do 2 sample t-tests and 2 sample confidence intervals to see if something like a medicine or an herbal supplement or something like that works better than a placebo. Okay, as always, let me know if you have any questions.